We're doing some questions here which involve Pythagoras theorem. This might take you right back to high school in grade 8. You probably did this, so this is probably revision for most people. What we're trying to do with Pythagoras theorem is find the unknown side of a right-angled triangle when you know two of the others. And Pythagoras theorem says that the hypotenuse side, the longest side, the square of the hypotenuse is equal to the sum of the squares of the other two sides. In this triangle here, if I'm trying to find out x, then x squared will equal 12 squared plus 5 squared. X is the hypotenuse side, it's the longest side, the side opposite the right angle. So that means that x squared equals 144 plus 25, or x squared equals, adding those together, 169. Now if I want to try and find x here by itself, I've got x squared. What I'll have to do with this little equation is take the square root of x squared to get x by itself. But if taking the square root undoes squaring, if I take the square root of x, I've got to take the square root of this side. So taking the square root of both sides, we'll find x. The square root of 169. I've done this one before, and I know the answer is 13. Here's another one. We want to find this side. Once again, it's the hypotenuse side, the longest side. And the rule says that that hypotenuse side squared equals the sum of the other two sides squared. So something like that. Now I've done some calculations beforehand here. 5.3 squared is 28.09. 7.2 squared is 51.84. Add them together. And so x squared equals 79.93. But I don't want x squared, I want x. So to get x, I need to take the square root of both sides. And the square root of 79.93 is 8.94. The next one is a little bit different. Notice here, the side that I'm trying to find out x is not the hypotenuse. I'm going to still set it up the same way though. Pythagoras theorem tells me that the hypotenuse side squared, 15 squared, equals the sum of the other two sides squared, x squared plus 12 squared. Now, the steps involved here involve a little bit more transposition. I've got to get x by itself in this equation. I want to have x equals something, or something equals x. Now to find that, the first thing I might do is try and move this 12 squared over to the other side of the equation. At the moment I've got x squared plus 12 squared. So to get rid of that, I've got to do the opposite of plussing, which is minusing. I'll take away 12 squared, and that'll leave me just with the x squared that I want. I'm trying to get x squared by itself. I take away 12 squared here. I've also got to take away 12 squared here. So that means x squared equals 15 squared minus 12 squared. Now, 15 squared, I've worked out beforehand, 225. So it's 225 minus 144 equals x squared. And that means that 81 equals x squared. And then we just take the square root of each side. That means x equals the square root of 81. And that means x equals 9. Now something about this, you'll notice that this question is different from the other two that we've done, in that we have got this minus in it here. Now some people would prefer not to set it up like this, and they'll go straight in and set it up as a minus question. If the question involves finding out the side of a right-angled triangle which is not the hypotenuse, you will always get a minus in your Pythagoras theorem statement. Now some people prefer to remember that. If it's a find the hypotenuse question. It'll be the sum of the other two sides squared. If it's a not finding a side which is not the hypotenuse, it'll be a subtraction question. In this next example here, that's exactly what we've got. This side is the hypotenuse. So the side we're trying to find is not the hypotenuse. It's going to be a subtraction question. So we can leap straight in, and rather than writing out a statement like this, we can leap straight in and say it's going to be a subtraction question. So that means that x squared is going to equal the other two sides squared taken away from each other, subtracted. And we can start our question from there, and it saved us a little bit of algebraic transformation. So what we've got, 8.7 squared is 75.69. Take away 10.24. And that means x squared is equal to 65.45, or taking the square root of both sides to find x equals 8.09. You might like to check those calculations for yourself. Practical problem here. We've got a kite. It's constructed from two pieces of dowel, lengths 90 centimetres and 50 centimetres. So these are the wooden dowel here. So one of them is 90 and the other is 50. Now this 51 is divided in two, but the symmetry of the kite tells you that this will have to be 25 centimetres here and 25 centimetres here to make up the 50. And it also tells you that the crossover point of these two is 30 centimetres from the top of the kite. So that's 30 centimetres, and that whole piece of dowel there was 90 centimetres long. I guess that means that this bit here has to be 60. Now there's a piece of string that's wrapped around the kite, and we have to work out how long it is. But that's not going to be too difficult, because you can see these are right-angled triangles. We could look at this right-angled triangle here and work out that length there, x. It'll be a straightforward Pythagoras theorem application. And then looking at this triangle here, we'll be able to work out this distance here, y. So what can we say? In this triangle here, the side we're trying to find is the hypotenuse side, so it'll be a addition type question. X squared equals 30 squared plus 25 squared. Do some calculations here. 30 squared is 900 plus 25 squared, 625. And that means that x squared equals 1525. Take the square root to find x. X is equal to 39.05 centimetres long. That's that distance there. And we want to find this distance here, y. It's in a right angled triangle. Once again, the side that we're trying to find, y, is the hypotenuse side. So that's going to make it an addition type question. So y equals 60 squared plus 25 squared. Now 60 squared is 3,600 and 25 squared is 625. So all up we've got 4,225, and that was y squared, wasn't it? And so that means that y is equal to the square root of 4,225, which equals 65. Now, we were asked to find out how long a piece of string which wraps around the edge and it supports the tissue paper that it's going to be covered in. So we need to find that, and we can do that just by adding together x. This will be x as well, won't it? And this will be y. So we've got two lots of x plus two lots of y. So the length that we need is going to equal 39.05 plus another one of those plus 2 lots of 65, and all up the total is 208.1 centimetres.